I'm just gonna share this. Oh, thank you. And you can see my screen now, right? Like through the stream too? Cool. Hold on. Make sure that's good too. Cool. All right. Can everyone on the stream hear me, by the way? Can you just double check?
Yeah, I'll double check, but let me add, there we go. Okay. Now people on the stream can see it.
Cool.
And I'm just going to double check.
Oh, and
Test.
Great.
Cool. All right. Well, hello, everyone in person, and hello, Virginia Beach and San Francisco friends. Good to have you all. Thank you for coming. So I'm Randall, and I know I met a bunch of you the other night at maybe the cloud security hangout thing we did, or like the Sneak Week security event that we did. But yeah, thanks for coming out. Super cool to see everyone. So today we're going to be talking about the 12 factors of pain and suffering, which is basically just a bunch of sad programming stories of things that I've personally sort of fucked up over the years and thought it would be funny to sort of share in a more professional venue, you know, minus all the swearing. And are any of you familiar with like or actually real quick, how many of you are developers real fast? Couple. And then are the rest of you security professionals, like sort of getting into things or what? IT maybe? Oh yeah, cool, awesome. And by the way, feel free to interrupt me at any time if you have a question or you want to add a joke in, that's fine too. And if you do if you're remote and you drop a message in the chat, Micah, would you mind relaying it to me?
Absolutely.
All right, cool. So how many of you are familiar with like this thing called the 12-factor app? Anyone? I'm going to pause for a second and actually pull it up because the website is 12factor.net. But if you haven't heard of it, this is something that I really, really, really like. It's basically this website sort of outlines these 12 principles for building scalable web applications, basically. And the guy that created this, his name was Adam Wiggins, and he founded the company Heroku, which I'm sure a lot of you know, the cloud platform. And I think I first discovered this back in, I don't know, 2012 or something, something like this. And it really changed the way that I thought about building web apps. And I was like a huge fan of it. And so this talk is basically me walking through all these principles and showing you all the ways I sort of screwed each one of them up. Because it's like a really insanely useful set of guidelines for building web applications. And the more I've written web software over the years, the more I really appreciated it. And so I thought that would be sort of the premise for the talk. So with that out of the way, I'll just give you my background real quick, but I'm Randall. I work at Sneak with Micah over here, and I do DevRel and community stuff, but I've been writing code for maybe 23 years or so, and predominantly nowadays I do a lot of Python, JavaScript, and Golang software for web and security things, but I also do a lot of open source stuff. So the particular things that I maintain there are some Python web libraries for Django, some Flask developer libraries for working with AWS, various security tools, and some cryptography tools as well. I'm an author, so I published a book on Heroku actually way back when, but I also write tons of articles and edit other technical books for like Python books and things like this. And the thing I would say I associate with the most though is just building things. And one of the things I personally just really love is just building side projects. And pretty much my whole career since I was a kid, I was just building lots and lots of side projects. And that's really where most of my experience comes from, is just trying stuff out, seeing if it works, and seeing if I can scale it up. So a lot of these stories are from that. So going back to that 12-factor app thing I talked about a moment ago, what it really boils down to is it's like a methodology for building simple, scalable, and dependable web apps. And like I said a moment ago, I'm going to walk you through all the ways I've screwed each one of them up. Because I always, some people learn things by like listening to stuff. Some people learn things by reading things. Some people learn things by watching people do things. I always tell people I learn things by just trying it and messing it up and then basically having to redo it. So that's why I'm doing this, because that's the way I predominantly learn. All right, so the first factor in this 12-factor application principles is really about best practices for managing your code base. And the idea is that you should always have one code base tracked in version control that you deploy many different times. And you probably think, okay, this makes a ton of sense. It's super duper obvious. How could this be screwed up? Well, the way I like to think of it is like this. You have your code in a project, like a Git repo, for example, and you deploy that same exact project from that Git repo to like a production environment. And maybe you have like different Postgres servers and different Redis servers and things like this, but it's going to production. But then you deploy the exact same copy of your code to staging and all of your development environments, right? This is pretty standard, I think, for most people. So back in the day, this was back in 2009 or so. We were actually, before some people came in, we were rehashing this a little bit, but I started this website with a friend of mine. And essentially the way the website worked was if you Googled a phone number in the US, you would land on our website. We were the #1 search result on Google for like 5 or 6 years. And you would see like something on Google that said, get more information about 818-217-9229, for example. So people would land on our website, and what we would do is we would provide all some metadata about the phone number. So we would say like who the person is, the approximate location of where this number was assigned. If it was a spam bot, people could leave comments like, this is a telemarketer or something, you know? Just all this metadata about phone numbers. And that was sort of the premise of the website, like give people this information. Now, the way we monetized the site was we had these affiliate links built into those pages. So if you like read this basic information and you're like, yo, I really want to figure out who this person or company is, you could click through to this partner we had, and they would basically pay us like $25 per click through because their conversion rate was insanely high and the lifetime value of their users was absolutely massive at the time. And so this website was like printing money for a few years, and it was ridiculously profitable. So we turned it into a business, and we had multiple people working on it and things like that. But this was like my foray into like entrepreneurship. But in 2010, maybe 2011, somewhere around there, maybe it was even later, 2012, Google search engine rolled out this really massive search engine change called Panda. And the Panda update basically completely like broke all the websites like mine that had a ton of pages indexed in Google search that like matched patterns. So things like phone numbers or like last names, things like that were like relatively common. Like if your site had millions of pages in Google, there's a pretty good chance you were getting like banned from Google search. Now, when this first happened, I was actually on vacation, and it was like the first vacation I'd taken in like 2 or 3 years or something. And literally like the first day of vacation, this happened. And my partner called me and said, yo, we have literally completely disappeared from Google search. And our revenues, like we used to keep a click track. So every day we would say, oh, we made $10,000 this day or whatever. It went from like $10,000 to like 1,000. And that was because the only people going back to the site were people that knew about the URL and were specifically going back to search. Literally no one was discovering us through organic search. And so it blew up the business like instantaneously. So I was like in panic mode on vacation. So what I did is I said, all right, I'm gonna like file an appeal with Google and figure out what's going on. And in the interim, what I'm gonna do is I literally just copy and pasted my code base, and I purchased a new domain name. And I was like, hey, I'm just gonna relaunch this under a different domain name because maybe there's something like messed up with our domain or something, and that's why we got banned. I didn't realize this was a really big search engine change that they had rolled out. So I copied the code base, provisioned a new server, and I think it was on Rackspace at the time, maybe. Then I purchased the domain name, set up the DNS, and I changed the logo, and I changed the color scheme on the homepage of the site, basically. And I just literally hard-coded all this stuff in because I was trying to get it out really fast. So I did that. And I resubmitted everything to Google Webmaster Tools, so it would like get picked back up again and stuff. And what I noticed is within like 12 hours or so, our new website was ranking highly for some phone numbers. And we saw from this new site now a pretty steadily increasing amount of people coming to check it out. And so for the first few days, I actually thought, oh, all right, cool, we solved the problem. Maybe it was like some weird Google issue. And I started the appeals process for the original site, but I was at least happy that we had some money coming in from this and we weren't like gonna go bankrupt, you know? But then about 5 days later, this website got banned too. And so I was like, oh my God, this is terrible. So what I did is I actually copy pasted the code base 2 more times. And I was like, all right, this time what I'm gonna do is I'm gonna do the same thing as before. And at this point, I was starting to realize this must be some sort of search change, right? So we're making no money. So the idea is, how do we stop the bleeding and then start to solve the problem? So I copied the code base twice more, bought 2 new domain names, 2 new servers, set everything up, customized more stuff on the pages, like structure in the HTML. And my thought process was, maybe I can trick Google and maybe like I'll be able to like get them to not recognize us as being some spammy site or whatever. And so I did this. So both of these sites got indexed, but then a few days later, they both got banned. So then what I did is I basically wrote some scripts that would literally just like copy and paste my Git repo and then basically run sed, like sed-i, s, whatever, and just like use regex to relaunch these sites under different domain names while I was still at the same time maintaining all these sites and trying to figure out like why things are getting banned and what I can do to do analysis and change it up, whatever. So this entire experience was absolutely brutal. And this is sort of the way that I screwed up that principle. Like the smart way for me to have done it in hindsight would have been to not panic and like try to do the fastest possible thing. I think the smarter thing to have done would have been to spend a little bit more time up front and properly templatize my original project and have maybe some environment variables for like colors and domain names and all these other things that I could have, you know, spat out lots of different things instead of having to work with like 50 different copies of the same project that I was constantly going into all these folders and updating and managing across all these things. It was just like a state management nightmare. So that experience sucked. And that's how I learned about the first factor, the 12-factor app, like how to properly manage your code base. All right, so the second factor in the 12-factor app is all about dependencies. And this one, again, actually sounds pretty straightforward. The idea is that when you're building web apps, you want to explicitly declare and isolate all of your dependencies. Now that is pretty standard, like everyone knows this, but just as a recap, here's how it works. So you're building a project, and the first thing you're supposed to do is declare dependencies, right? And this is pretty straightforward. So if you're building like a web app in JavaScript or Node, whatever, for example, you're gonna like freeze your dependencies. You get like a spit out saying, hey, you're using this dependency at this version, this other dependency at that version, and that's great. Then when you go to like, you know, run a production deployment or whatever, you're going to isolate your dependencies, AKA you want to be able to recreate the environment. And so in the case of a JavaScript app, you might say npm install. It's going to read your declared dependencies, install everything, and then you have this nice environment set back up exactly like you want it, right? So this all makes sense. Well, you might be wondering how I could potentially screw this one up. So here's the second story. So for a hobby project years ago, I had built this image optimization API. And the idea behind it is basically this. So you have a user, and the user has a website, and the website has images on it. And what you want to do ideally is losslessly compress your images so that their file size is as small as possible, therefore allowing your users' pages to load faster and take up less bandwidth. And so if you have this image, like this super cool image I found of a crow with a knife in its mouth, you might want to optimize it to use less file space. And so you would send that image to the image optimization API. And the API would say, okay, I'm going to optimize this image. And then it would optimize it and send the smaller version back to you, the developer, to then use in your website or whatever it is you're building. So it's a really simple concept. Now, the way this worked behind the scenes was I had a VPS server running at the time. And I logged into it. It was a Ubuntu server. And I installed a few of these popular command line tools at the time. So there was something you could install like OptiPNG, JPEG Optum, DevSecCon, all these different like open source command line tools. And what these did is these would essentially optimize these variety of different image file types. So like OptiPNG would only work on PNG images, but it would essentially compress them. Same with DevSecCon, it would do the same thing, but just for GIFs. They were each like pretty specialized. So the way the API worked is in my code, if I got an API request for someone to say like, hey, I want you to optimize this image, I would literally shell out in my code to run these command line apps. And then I would take the output file they generated and send that back to the user. So that's like how the API backend worked. And this all worked fine. I actually launched this API and it was like, I was using it for personal projects and it was like fairly popular. And I noticed over time it had more and more usage. And I got to the point where I started getting a lot of emails from users saying, yo, your free API service like isn't working anymore. I'm just getting a bunch of 500s. Can you look into it? And it was purely because there was a massive queue and I hadn't like built any proper queuing or anything like that. And so I thought, all right, I'm going to scale this thing up. So I provisioned a web proxy in front of it, and I put two servers, a load balancer, my God. So I provisioned a load balancer, and I provisioned a second server, a second VPS server. I put it behind the load balancer, and I literally was like, this should be really easy. Same version of Ubuntu, copied over my project in the Git repo. I ran my npm install. This project was actually written in Node, and I expected everything to just work. Well, I realized pretty shortly thereafter, things like were not working. And the reason why was actually because, and I realize I don't have another slide for this, but the reason it didn't work is because my project was built in Node, all my dependencies were declared, but not these command line tools. And so the API would run and it would shell out and expect these tools to exist and run, but they weren't there. And so like it was failing. And so the lesson I learned is if you go back to this, this rule in the 12-factor app about dependencies, the key thing to remember is you want to explicitly declare and isolate all of your dependencies, not just some of them. And at least for me, it wasn't always obvious, like in situations like this, that your dependencies is literally everything. It's not just like your Python dependencies or your JavaScript dependencies. It's like everything you need to reproduce this, whether it's command line tools or whatever you're building. And so nowadays, the solutions to this is maybe use Docker images to have like an entire instance set up with everything, including your web servers, your code, your OS dependencies, whatever. But just don't do it the way I did it, basically, and you should be a lot better off. Okay, so the third factor in the 12-factor app. This one's all about storing configuration for your web apps. And what the 12-factor app states is the ideal place to store config data for web apps is usually in environment variables of some sort. Now, what are the config things we're talking about? It's settings for your web application. So things like database URLs, prices, API credentials, things that your web app needs to access quickly that like determine how things work, where infrastructure is located, etc. So the way I violated this principle was back in the day, I was building this telco-based application. This was in like, I don't know, 2008, maybe, something like that. And the entire application I was building was built on top of this open source software called Asterisk. And Asterisk, for those of you that don't know, it's like a free open source like PBX phone system. And so you can program it to do things like send and receive phone calls, SMS messages, all sorts of stuff like this. And the way this application worked is it was like a free teleconferencing system, all right? Think of like freeconferencecall.com sort of, and this was the bit that powered the actual phone parts. So I was at the, so this application was running in a hybrid environment. It was running like partially in data centers and then partially on rack space. And so this thing was getting deployed to rack space. And the way I screwed this up is I was trying to build out like the auto scaling component for my application that would allow me to automatically provision additional rack space servers when we received too many inbound calls to properly serve. And this way, we'd be able to route new callers onto a new server and just support an unlimited amount of demand, ideally. And so at the time, I was using Puppet. Any of you familiar with Puppet, the configuration management software, a little bit? Well, I was using Puppet to basically define all of my Asterisk configuration files and all the packages and services that had to be running on these rack space servers in order to make everything work. And it was all open source on GitHub. And so I got to the point where I was almost ready to deploy this new auto scaling software. And I tested things out extensively in my local environment. But I got to the point where I wanted to finally get it to the point where not only could I take an existing server and use Puppet to provision it, but I wanted to get to the point where I could actually provision brand new rack space servers and have them fully provisioned like on their own. So like bootstrapping basically. So I wrote some code, some bootstrapping code as a simple Python script. And what it did is it used my Rackspace API key that I got to say, hey, Rackspace, create a new server. And then it would SSH into the server. And then the script would literally copy over my Puppet configuration files, run the Puppet tool, and that would bootstrap the rest of the server. So what I did is in my haste to get this thing out, like I said before, this is all open source on GitHub. I copied my API key from Rackspace and I hard coded it straight into my GitHub repo. And the reason I did it is because I was like in a rush and I was trying to get this thing working. I had like no stars or followers on the GitHub project, and I thought, no one's going to see this thing anyways. Like, even though I know this is a bad idea, it's totally fine. And so I pushed this thing live, and very shortly thereafter, someone was scraping the public GitHub repos looking for sensitive API credentials like mine. And because I had copied the sensitive API credential into my GitHub repo, an attacker was able to find it and then start provisioning really large rack space server instances that cost me a ton of money. So, whoops. So basically, I got these emails the following day when I realized this was happening, saying that I had a negative $25,000 account balance in my Rackspace account. And at the time, I was super broke and had no money to pay for this type of stuff, so I was freaking out. Well, eventually, I talked to Rackspace support. They helped me figure out what had actually happened. I didn't realize it at the time that my API key had actually gotten abused. I thought it was something else. And ever since then, I've been storing sensitive credentials in my environment variables, and sometimes even using additional services to outsource those things. Like there's lots of things on AWS today, like AWS parameter store is a great place to store sensitive credentials. You can then load them into environment variables. There's also HashiCorp products that do this, all sorts of great things, but it's a really nice way to do it versus hard coding stuff or not relying on your environment at all for things. All right, so the next factor in the 12-factor app is all about backing services. And basically what it says is you want to treat your backing services as attached resources. Now, that sounds relatively complicated, so let me explain. You have a production deployment running somewhere, and basically production deployments usually require some sort of external resources to work. So maybe that's an SMTP server if you're sending emails. Maybe it's something like an Amazon S3 bucket where you store files. Maybe it's something like a database server like Postgres. And your production app has to talk to these external resources to like fulfill requests, you know, like doing stuff. And so basically what the 12-factor app principle is stating here is that when you have all these external services, what they call backing services, you want them to be treated as attachable resources, meaning you should be able to attach a new S3 bucket in here and replace this one at any time. It should not be a hard thing to like add in or remove, basically. You want it to be a really simple change to update these things so that if a server goes down, you can replace it. If you want to switch a server or a service out, you should be able to easily replace it and swap them in and out at will. So this story takes place way, way, way back when. This is when I was like a really young kid, maybe like 13 years old or so. And I started building a blog for the first time. And at the time I was like really into programming, but I was a total noob. And I was building my first website, and it was this like really terrible shit PHP CGI mess of a blog. It was all hand coded, and I was having a lot of fun working on it. And this blog I worked on from the ages of like 12 or so, all the way till I was like 20, let's say, something like this. It was the same code base this whole time. And this code base was running, like I said, PHP and CGI files on one of those shared hosts, you know, like a fat cow type situation. And it was just using MySQL, the free built-in shared hosting MySQL that was on localhost with like no username and no password. It's just like there for you to use, basically, using default ports and all that. So when I went to university, I went to get my computer science degree at UC Santa Cruz. And I was extremely introverted back then, and I didn't really know how to talk to people. And so I thought, all right, one way I could like make friends at college would be to give out pirated movies to people, because I was, you know, downloading stuff illegally, and I thought it was awesome, and other people like didn't really know how. And so I thought, this is how I'll make some friends. So what I did is I signed up for the Netflix DVD plans at the time. This was in like 2006. And we would get like the 4 DVDs per week. So I'd get the DVDs in the mail of the popular movies. Then I would use this Perl program called DVD Rip. I'd rip them into AVI files. Then I would just upload them into my shared web host. And so I had this massive like hidden directory on the website where people could go to download like all the popular movies. And when I met new people on campus, I would just like give them the URL and say, yo, if you want to check out some pirated movies, like come check it out. And I like made a bunch of friends this way. So it was going pretty good. But at one point I ran out of disk space on the shared host, and I thought, all right, I've actually been working on this project for like 10 years at this point almost, or 8 years, whatever it was. And it's finally time that I need to clean this up and turn it into a proper project because I have a lot of people using it, mainly for piracy, but like, it's pretty cool. And I was like, I want to maintain this over the long run, so I finally need to like set it up properly. So what I decided to do is I said, okay, I'm going to break this into components. The first thing I'm going to do is I'm going to take all the data I have in my local MySQL database and migrate it into its own dedicated MySQL server. And then I'll eventually move things out, like all the pirated movies, into a file server and just like refactor everything. Well, when I set up the new MySQL server, I dumped the old database, copied everything over to the new one. And then I was like, all right, it should be relatively easy now for me to just go and update my website code to point from the local MySQL server to the new MySQL server. And that's when I ran into issues. And I ran into a bunch of issues because I realized that in all of my hundreds of PHP files with like hundreds of thousands of lines of code, like us hacked together over like 8 or 9 years, I had always assumed that MySQL would be running on localhost with no username and no password. And so I had to go through like hundreds of files looking for every single MySQL_connect statement and then manually go update them to talk to my new external MySQL server, which had a username and password and ran on an external host, with a different IP address and such. And this is why I think this 12-factor principle about backing services is so important, because my database was a backing service. I was relying on it. And had I treated it as an attachable resource and just had a single place where I defined, hey, here's your Postgres connection string, for example, and being able to change it that one place and have it work everywhere would have saved me a ridiculous amount of time actually getting this thing working. So this is the way I violated that principle and sort of how I learned that lesson. All right, next. Build, release, and run. So the 5th factor in the 12-factor app basically says you should strictly separate the build and run stages of your application. So what does this mean? Well, if you're working on a project, you have some code in the code base, right? And then when you're going to do a deployment, what you would ideally do is create a build artifact. And then you would take some configuration data. So for example, if you wanted to deploy something to a production environment, your configuration data might be all the environment variables that hold all of your production, like Postgres URLs, API keys, things like this. And you want to merge both your build artifact and your configuration data into a release artifact. And then this is the thing you would then go and deploy to different places. Now, this, I think, makes a lot of sense. People sometimes do it differently, but I think this makes a lot of sense because you're clearly separating these stages. You have your code where you're running code. You have a build step where you're building some sort of thing you're going to deploy, and all your config data is separate, and then you eventually just merge them together, and then this is the thing that gets deployed. Now, if you do it this way, it's nice because you can track releases separately from one another. You can roll back releases. You can do all sorts of fancy things. But this is just like the principle. Now, going back to that personal website I had as a kid, I also screwed this same factor up on that personal site. And so I was a total script kiddie back in the day. I had no sense of like what good development practices were. And when I was working on that personal website, the way I did it is I had my website code on my desktop computer at home. And I would write the PHP code, then I would SCP it over to my web host, and then I would reload the page and see if it worked or not. This was like my typical software development workflow. And so I would do this all the time, literally just copy the code up to the live web server. And what I learned is over time, like this is actually really annoying to do because if you've ever done this, you realize that this command gets really slow as you have more files. And so every time you make even a tiny little syntax change, it just re-uploads all of your crap to the production web server, and that takes a while before you can see the changes. And I didn't really know any best practices at the time. And so what I decided to do sometimes is I said, okay, well, this is taking too long. So what I'm going to do is I'm just going to SSH straight into my production web server. And I'm just going to use Vim and just like edit and make code changes here on my own directly. So that way I can reload the page instantly and see if it worked or not. But then the problem was I'd eventually get code working in production, but then I'd want to copy from my archive. So then I would like SCP the code from production back onto my local environment. But then sometimes I would make changes there too. And so I'd have to like almost be like my own version of git diff in my head, moving code from development to production and vice versa. And it was just insanely frustrating and confusing. And yeah, it was a huge pain. So it was just really frustrating doing that. And that is how I learned that lesson about separating those environments out and those stages of building. Now, going back to this factor principle real quick, had I actually done things the right way and kept my code in one version, like here, right? And then every time I want to do release, I create a build artifact. Maybe I package up all my things into a tarball or something. Then I take all my environment variables and package those up, and then SCP both of them over, or create a release artifact, and SCP them all over at once. It would have definitely sped the process up because I wouldn't have had to go back and forth as much. I wouldn't have had to wait for 100 files to get copied over, and it just would have been a lot cleaner and would have saved me the mental anxiety of like constantly changing and keeping software state between all these different back and forth versions from development and production. So that is why it is nice to keep those things separated. Okay, so the next factor is all about processes. So this factor states that you always want to execute your web app as one or more stateless processes. So the key here is stateless. Back when I was building that free conference calling application, I'm going to go back into this a little bit to explain this. The way this worked is this application was deployed, like I said before, on-prem, but also in the cloud. And so the on-prem portion would literally go out to data centers and install these 1U rack-mounted servers to host all of this Astra software that was powering things. And we had physical phone lines, PRI lines, plugged into these servers in these Sangoma carts. And basically, we had multiple servers running. Each one of them was running this conference call software. And one of the cool features of this software is that you could go to our website and you could say, hi, I'm a business. I would like to have a free conference calling phone number. And we would give you a dedicated phone number to make conference calls on. So we would give you a number. Now we had like a ton of these numbers. And so we would do a mapping where we would assign like particular phone numbers to particular servers. And so like we'd put like 500 phone numbers, for example, routing to a single server because we could roughly sustain that much traffic. Now, one of the reasons people really liked using our free service was because they could fully customize the audio files on their teleconferencing line. So they could call into their line, hit an admin code, and then re-record the voice prompts themselves. They could change it however they wanted. It was super popular. And when they recorded these new audio files, I would save those to whatever server their phone number was mapped to. And so if they were calling in onto this conference line and making changes, the audio files for that conference line would only exist on this server. Does that make sense? No. Now, this worked really well, generally speaking, except when things broke. And so every now and again, a server would completely go offline. And this is in like remote data centers in the middle of like Illinois, for example, and Texas and stuff. And so I couldn't just call and get remote hands to go in there and reboot stuff or whatever. It was like a flight. And so sometimes things would go offline. And the problem was that the application was not architected to have any failover because these audio files for this phone number only existed here. When this server failed, we would reroute the conference calls from the main router into an alternate server so that their conference line would still work, but none of their custom audio recordings were there, and people would get so pissed off every time that happened. And so that's because, according to the 12-factor app, your app should consist of a lot of stateless processes and not stateful processes. And in my case, I treated the entire thing as very stateful. I made the assumption that all these files will exist on each server, that it's no big deal. But had I built it a little bit differently, and I'm actually going to talk about that in a minute, it would have been a lot smoother. So this is another good example of like how you can actually screw this stuff up in the real world. Okay, so now let's talk about port binding. This is the 7th factor in the 12-factor app. AKA, you always want to expose your services via port binding. Now, this one, I will definitely admit, is actually not really relevant today at all because no one really deploys web apps straight to like dedicated servers anymore on the public internet. But the concept still holds true, so I'm just going to breeze through it. But basically, if you have a public-facing web server and you literally have a dedicated server, an IP address or domain name is pointed to, and you wanted to run a non-TLS site, like an unencrypted site, what you used to do is just bind your web application to port 80 directly. If you wanted to have an encrypted site like HTTPS, you would bind it to port 443. And people used to like hard code this in all the time. But the idea is you just don't want to do that. Whenever you build a web service, you always want to have the capability to bind it to any variable port number, basically. And so ideally, your application should treat the port number as an input variable and let the routing layer of your infrastructure tell your applications what port to bind to. This way, if you're running on Heroku or Google Cloud or App Engine or wherever the heck your application's deployed, your app will be flexible enough to bind to whatever port it is assigned, and therefore you can plug into all sorts of really cool dynamic routing and cloud environments, and you won't have issues making your app more portable. So I'm not going to tell any other story for this one because it's really simple, but like that's just the general idea. All right, so next, concurrency. So ideally, when you're scaling applications, web applications, you want to scale out via the process model. And all this means is that, like, imagine you're building a relatively complex web application. You have these different types of processes that make your app work. So for example, you have your web app, right? The thing running your web server, processing requests and fulfilling and generating responses. Ideally, you'd be able to provision or deprovision web applications to support more load horizontally. So you could have like a load balancer that routes requests to web server 1, and then if you have too much load, you provision web server 2 and start routing requests there. And then maybe you have less load, and so you can deprovision that service and have everything go back to web server 1. But you want to be flexible in terms of your horizontal capacity. Well, there's also other types of processes that make your web application work. Like for example, you have background workers that are processing items in a queue. Maybe you're encoding videos or something, for example. You don't want to do that on your web server. And so you have different types of processes you run to do this. And what this means is you should treat these exactly the same as your web servers. You should be able to add more of them to like process things faster or decrease them when you don't need them. And there's all sorts of different processes people use for building things. In the telco world, we use a lot of like clock processes to keep audio in sync over voice over IP calls, but there's all sorts of things. And so it's basically saying you want to be able to scale your application horizontally to take advantage of like cloud environments. So the way I botched this one, this is back when I was like 14 years old or something. I was living at home with my family, you know, going to high school and all that. And one of the ways I learned a lot about programming was just through hanging out on IRC. And I used to talk with programmers in the C programming channel on Freenode a lot. And basically I had this idea back then, which is I wanted to build like a web version of IRC because that didn't really exist at the time. There were things like IRSSI, like command line clients and things, but there was no like popular web app for like accessing IRC chat rooms. And so I decided to build one. And I was writing this in like pure C, by the way. So it was like a terrible idea, but I didn't know that, you know? So when I went to work on this, I was becoming like a reasonably like, you know, noob C programmer. And I knew a little bit about like concurrency. I learned about inter-process communication through reading this guide online called BJ's Guide to IPC Programming, which is still really great. But basically, the way the software would work is every time someone joined the website and joined an IRC channel, it would put them in an IRC room and it would literally fork in like the C code and create a separate running thread, essentially, to keep the connections alive to each IRC server and each IRC room, and then would relay all the stuff that happened in that socket like back to the web application. Right? So it would like pull and just refresh your browser, but this is how it would work on the back end. And as I had some friends start using this in beta, I got really good feedback. People were like, oh, this is pretty cool. I can like talk with my friends and I don't really need to know a lot about like how IRC works. And I thought this was going to be amazing. And so I spent a lot of time working on this project. And I decided to make it scalable so it could support more than just like me being in like 20 channels. I was going to turn this thing into a Linux system daemon. And so what I did is I actually created a proper daemon. It ran under the init system in the operating system. So every time the server booted up, it would literally fork off all these child processes to maintain state and maintain connections for all the IRC rooms that people are joining. And this worked like sort of kind of okay. So I was doing a lot of like IPC magic within here to send data and chat conversations from one worker process or one worker thread back to the main web application, but it was extraordinarily complicated to maintain. And I was, again, a relatively noob C programmer. And what would happen sometimes is IRC servers would split or they would have a networking issue. And one of my child processes would die or be killed off. And that would start cascading issues where basically everything would die off. The daemon would die. The OS service would restart, and all of my users would be kicked from the system and then have to reconnect. And so it was like a terrible user experience. Well, I worked on trying to debug this issue for like a ridiculous amount of time. I was never able to resolve it. And so I eventually just got bored with the project and gave up on it and told people like, sorry, I couldn't figure it out, you know, like it just wasn't meant to be. But thinking back in retrospect, I think had I understood like this model of scaling things horizontally, I would have approached this project completely differently. Like instead of having one massive process that was supposed to like add and remove capacity on demand and handle all this state, I would have treated things like statelessly. And I would have tried to figure out, all right, what is a way that I can break the communications part into a separate process that I can just add and remove instances of? How can I treat the web app as a separate process to reduce that dependency and the likelihood of failure when something bad happens on the networking side of cascading into my web app? You know, like I think had I architected this differently, there was a good chance that I could have actually built this thing out and had a lot of users and stuff, but it was unfortunately not meant to be. So that's my story about scaling things out via the process model. So we're getting close to the end, you guys. Disposability. So this factor of the 12-factor app talks all about the fact that you really want to try to maximize the robustness of your web apps with making sure that they start up really quickly when you start them, and they shut down gracefully when they are killed. So what does that mean? Well, if you have a web application and you get a SIG term event from the operating system, you want to shut down gracefully, which means you want to like finish processing whatever you have. You want to save whatever state you need to continue on properly. You just want to do it nicely. You also want to shut down quickly. So you ideally want your app to shut down within a few seconds. And this will become important later. And you want to be robust against sudden death. So what that means is if like the power is yanked and your code just stops running, you don't want that to completely blow up whatever logic you have in your application. You want to be able to recover from those types of issues. So going back to that teleconferencing app, we had a lot of requests coming into a load balancer. And this load balancer at the time was basically, so this was in the cloud version, like in Rackspace. And what I had done at this point is when calls were coming in, some of them would still be routed to our physical infrastructure in data centers, but some would be routed to this Rackspace-based cloud environment that I'm about to show you. And at this point in time, I was getting around the issue of that statefulness before, where like audio files would be lost when people's apps would go down in the data center. So I'd architected this way specifically to help avoid that problem. And I was getting to the point of getting this into production. So this is just the background of the story here. So I got it set up to the point where when calls would come in, they'd be routed to one of these Rackspace instances. And each of these instances was running on a Rackspace server. And I had just gotten auto scaling working. And so ideally, if we received too much call volume, we would provision a new server and start routing calls there. So that's like how this stuff worked. The problem I had though, when I finally deployed this into production, is that when, like let's say a lot of calls came in and we provisioned server 4 and server 5, what I noticed is that our capacity never really increased. And when I looked into the logs, I realized it was because these servers would never actually like start up all the way. And so I can never see them actually start processing new calls. And I was trying to debug it and figure out why. And what would happen is I would see that the web application would start up and the Asterisk application would start up, but it would never bind to the proper port to start accepting the inbound calls. And it would just wait about 30 seconds and then it would be killed off by the operating system and then restart. And that was like literally what was happening. Like I just thought every 30 seconds the process would be killed and just start up right again. And it would never bind. So I was debugging this and thinking to myself, what the hell, this is so weird. And then after staring at the code for a while, this was all written in a Python and Django web application, by the way. This is some pseudocode, but this is almost verbatim, like what the actual production code was. There's a startup routine. And in the startup routine, what I would do is the first thing I'd do is I would download the audio files that were needed to run the teleconferencing lines. And then after that was done, I would bind to the proper port so that I'd be able to start accepting inbound calls from the load balancer. And this code looks relatively straightforward, right? Anyone have any idea why this did not work for me? Micah knows probably.
Lots of time downloading before it could bind to the port.
Yes. So what would happen is I had accidentally, this function to download audio files would literally connect to the file server and download like hundreds of gigabytes of these custom audio files for every single phone number we ever had. It wasn't just downloading the ones it needed to process the small number of like teleconferencing lines that this service was going to handle. It was downloading all of them. And that took way more than 30 seconds. And so what happened is the load balancer that triggered this auto scaling software would say, oh yeah, let's boot up a process. But then it would wait 30 seconds by default. And if it didn't bind to the port, it would say, oh, we'll just kill the process and let it restart. And so it was constantly just restarting and never running. And that was why. So anyways, the reason this is relevant is because going back to this principle of disposability, I wasn't really following it, Like my application didn't start up within just a few seconds. And that was one of the main issues that, you have to have fast startup, graceful, quick shutdown. Otherwise, you can run into weird edge cases like this one where it can cause all sorts of like cascading issues that you may not realize without a lot of debugging. All right, so up next, dev and prod parity. So this is one I'm sure all of you that have written code before are familiar with, but there's this general rule, right? You want to keep your development, staging, and production environments as similar to each other as possible. So what's a good example of this? Well, I build a lot of websites today and I write them on my laptop most of the time. And I'm a fan of Postgres for database stuff. And so I predominantly use that. But oftentimes when I'm testing code out on my laptop, I'll test it out using SQLite because they have the same API, but I don't need to actually set up and install a Postgres server on my laptop and have all the settings be the same. And I mainly just do it because I'm lazy. But there's been a number of times when doing this where I'll write some code, test it out thoroughly on my laptop, and it works great in SQLite. Then I deploy it to production and get all sorts of weird errors. Like for example, one of the things I learned the hard way is that if you define a database varchar field and you put in a limit, like a 50-character varchar field, Postgres will enforce a 50-character varchar limit, no problem. SQLite will see that and just make it an unlimited length text field and won't care what the actual numeric limit is. And so something that I was writing that I was testing locally would work just fine, but then it would go into production and blow up because my development and production environments were using different services and they weren't very similar to each other. And so I just had all sorts of issues deploying to production because my environments were so different. And had I just made sure I was using the exact same stuff everywhere, it would have probably saved me a ridiculous amount of pain. Now, this particular lesson, unlike the other ones, I will say, I still probably don't do this today very often. I don't keep them the same because I find it extremely convenient to use SQLite personally, but you absolutely should always keep the environments as similar as possible if you don't want to screw things up. Okay, so logs. The 12-factor app states you should always treat your logs as event streams. So here's an example. You have an application, right? Your application generates logs. And the rules are your log should always be ordered by timestamp. You should always write them to standard out. And you should then have some logging aggregator services pull those into some different places so you can use it when you need it. And your logs, importantly, should always consist of all of your process and backing services. So what this means is your Postgres logs, your SMTP server logs, your web server logs, all those things should be labeled as being from Postgres or web server, whatever, but aggregated into one place ideally, so you can actually recreate situations when you need to. Now, this particular lesson, this is extremely embarrassing to admit. This cost me about $500,000 at the company I was at the time. And so I'll explain this, but this is all these are true stories. So that free conference calling company that I started with a friend of mine, we bootstrapped that. So we didn't have investor money. We didn't have any money. We were pretty much just barely out of school. And we were literally just paying every single month the bare minimum cost of these data centers and to make this company run. But we were living off of nothing, no money at all. And we were completely broke. So we had gotten this free conference calling company to the point where it was starting to make a decent amount of money from nothing again. And we were, maybe pulling in around, and this is gross numbers, not profit, but $1 million a month from this conference calling application. Now, the way we made money on this is we would take these we'd basically partner with rural telecom providers around the US. So we would go to places like Mattoon, Illinois, Lufkin, Texas, like Coplay, Pennsylvania, all these tiny little cities. And the way it worked is the government would incentivize these companies to build infrastructure, telco infrastructure, in rural cities. And the way it did that is it said, hey, Gary, if you start a telco company in rural Pennsylvania, usually there won't be enough people living around you to subscribe to your service for you to make money. And so what we're going to do is every time you receive a phone call into a number that you own in your data center, for your telco lines, we'll subsidize and pay you an extra amount of $1 per minute for inbound calls. So basically they're saying like, the more usage you get from your people, we'll just like inflate your profits essentially. And so what we did is I would go and talk to these data centers with my friend and say, hey, we have an extremely popular free teleconferencing platform. And if you let us run it out of your data center and give us the resourcing to like plug it in and everything, we will drive a substantial amount of call traffic into your data center, and we'll split the government subsidy money 50-50. So we'll keep 50 cents per minute and you keep 50 cents per minute. And that was like an extremely appealing proposition to these small companies. And so that's how the business model worked. Well, here's the technical side to it now. So there's this web application that people would use to get phone numbers and sign into the conference calls and all that. And there was a Python-based API service as well. And then there was all these on-prem Asterisk servers that were not in the cloud that were at these data centers. And the way we actually got money is every time someone called in to one of these servers, Asterisk would record like the person who was calling their phone number, the phone number that was being called, so we knew which conference line it was, and like the start time of the call and the end time of the call, so we knew how long it was. And this data would be collected on this API server here in the centralized place. And I would literally write all of those records into a single CSV file called like calls.csv. And it would just have all the billable call details. Now, this CSV file, what I would do is every month, because these are like rural telecom providers, they do not have like the sophisticated operators to be able to tell me how much call volume we were generating for them. They had literally zero insight into this. So what I would do is I would go on my desktop once a month and I would literally SCP this massive billable calls.csv file from the production server onto my desktop. Then I would like scan through it a little bit, make sure things looked right, send it to my partner, and then we would generate like a proper invoice and send this CSV record to the phone company. And they would have a receptionist there, go through, total up the minutes that we'd used, and then match it against the start and end times of the calls and the phone numbers that were called. So they could check it against those things. They just couldn't tell us what it looked like without the verification. So this is how we finally got paid at the end of every month. Well, I would run this report. I would like copy this file over like all the time and give my partners an update. Like, hey guys, this is amazing. We just got like, an extra 50,000 minutes this month. Like this is incredible. Or we're on target to get an extra 10K or whatever it was. And we were really excited. So one day I go do this, and what I noticed is that the number of minutes we had was the exact same number of minutes that I had the prior month. And I thought, that is so weird, because it was about the middle of the month when I ran this command, and I was like, what are the odds that halfway through this month, we have the exact same amount of minutes as we had for the entire duration of the previous month? Like, that's just such a huge coincidence. So I started looking into it, and I was like, God, this is so weird. I'm looking at the call files. Everything looks fine to me. But then I realized that the dates and timestamps were from the prior month. And what I realized I had done is I'd actually reversed these SCP arguments. So I actually copied the prior month's call files that I had downloaded locally and overwrote the version that I actually had on the production server here. And I was like, oh shit, not a big deal, right? But then I remembered, I was like, oh my God, this is actually a really big problem. And the reason why is because, let me just explain this real quick, because this is like burned into my brain. These Asterisk servers, like I said before, they're running on-prem, okay? And they would generate a ridiculous amount of log file volume. And I used to have issues where these servers would go down because the disk would just run out of space. These are like 80 gig hard drives, basically. And so I specifically built this calls.csv system on the central server so that I could explicitly disable logs completely on these dumb servers here. So I completely disabled logging to keep these things running. So the only log that I had was the calls.csv thing here. As a matter of fact, I didn't even keep web server logs. This was all deployed under Apache. I explicitly turned all of that off because I thought, oh, I don't want my central web server to run out of space either, and it'll just make it simpler. And since I have this single billable file, I can just use that and keep things really simple. Such a stupid idea. Because when I overwrote it, there was literally no way to recover this. And so because of this particular incident, at the end of the month, we couldn't send them the calls from the prior month. So we literally lost like around, $500,000 basically of potential revenue because there was literally no way to prove that we had generated any of these traffic calls for them. So that was like a massive mistake. Now, going back to the 12-factor app, had I done this properly, what I would have done is use some sort of log routing software. There's tons of different ones you can use, all sorts of things, but basically every part of your application should ideally be generating their own logs, and you can just aggregate that someplace so that even if I would have deleted this stupid calls.csv thing, which I now realize is a terrible idea to begin with, I could have at least gone back through my logs and recreated things by piecing together all these different sources. But I explicitly didn't do that, which is what cost us about $500,000. So that's the reason why I think that's a really good principle. All right, finally, the very final factor is all about admin processes. So the 12-factor app basically states you should always run your admin, aka management tasks, as one-off processes. So what does this mean? Let's say you want to run a database migration, all right? So you're deploying a new feature, whatever it is, and you have to add a new column into your database. So what you would do is you would create a migration script that would, alter your table structure and add whatever stuff you want. You would package this up, so you'd code this thing. You would create an admin task, like a function you would run from the command line or whatever, and you would deploy this, or you put this in your code base and you deploy it to production. And then if you wanted to actually run this task in production, you would fire it off the way you would any other web process, like scaling up a new web server, for example. You would say, oh, I would like to run this particular management task, and it would go and fire off a new instance, run it in production, and then close the instance down when you're done. This is the ideal way to do it in the 12-factor methodology, all right? So my particular story of how I screwed this up was a database migration as well, and I'll just sort of talk you through what I did. So I was working on a new feature for that teleconferencing software, and it relied, just like I said a moment ago, on altering a table to add a new column to the database. And so I wrote this database migration code, so it would execute the alter table statement, but I only needed to run this once, this migration command once. And so I thought, I think I'm gonna skip the part where I check it into GitHub and actually deploy it to prod and then run the thing. I'm just gonna run it locally. And so what I did is I said, all right, I literally just ran the database table schema migration stuff locally. I executed the code. It ran without errors. And I did some testing on localhost and things were looking good. And so I deployed my final new feature stuff straight into production. And I was like, this is gonna be great. And it was going through a Jenkins CI system and all this stuff. And I basically signed offline. I was like, all right, we're good. It's been extensively tested. Well, an hour or two later, once the code actually hits production, my partner calls me up and is like, Randall, literally nothing works. And I just left for a day with my wife at the time. And I was like, what are you talking about? I just tested everything out. The new feature is working great. He's like, no, the entire application's down. No one can make or receive calls. Everything's completely host. So what I realized that I had done is because I didn't really adhere to those principles, when I ran this command locally, everything worked. But the thing I forgot to do was update the database environment variable URL I was using. And so everything worked fine and did the migration on my SQLite database that I was using locally. So the production database running in Postgres never received that alter table statement. And so therefore, it never happened. And so when I deploy this feature, it's expecting this database row to be there, or this database column to be there that doesn't exist. And so everything would just break in 500. So this was how I specifically learned the lesson to hey, even if you're trying to go fast, it's worth, especially for things like one-off admin management tasks where it's going to have some sort of, potentially devastating side effects, to go through the entire process like you would any other normal engineering feature, deploy it, run everything in separate processes, and just do it properly so you don't run into stupid issues like this. So that's all I got. Thank you for listening to me ramble for however long it's been now. But yeah, thanks for coming. If you did want to check out other stuff, just so you know, my personal website's rdegs.com. I've written about some of these stories there and other ones as well. And like I said, I work at Sneak. If you're interested in checking Sneak stuff out, that's like a security tool. Our Twitter is SneakSec, and our website is sneak.io. And it's free to use, so you can use it if you want. And yeah, thank you. Any questions or whatever? Any questions or anyone want to tell their own stories? Because you can use this as therapy if you want to.
I'm gonna bring Virginia Beach.
Oh yeah.
Y'all hear us in Virginia Beach?
Hello, Virginia Beach friends.
Hello.
Any questions or stories you would like to share?
All quiet over here.
Oh yeah. If what now? Sorry. Oh, how did I figure out about the Panda release? So I was on vacation for the first time in like 2 or 3 years at that point, and I used to work like 24/7 because it was like our own company and stuff, and we weren't making that much money early on, so it was very stressful. And we literally found it out because our revenues at the end of the day were almost zero. Like we went from making like a ridiculous amount of referral fees from this affiliate program every single day is when we would check it out. We would go from, I don't remember the numbers anymore, but let's say it's like $10,000 a day. We went from $10,000 a day pretty consistently down to like $1,000 a day, which was totally weird. And I checked the website, everything was working. I could search my own phone number and click the affiliate link, it worked fine. But then if I went to search for our site on Google, just using a site colon search, I realized it literally showed up not at all. Like it didn't show up at all. And so I realized they had removed us from the search index. And that's when I panicked and started doing all that other stuff to create all these like alternate domains. Yeah, and I actually didn't figure out about the search engine update until maybe like a month or two later, because there is a good period of time there for like 1 to 2 months when I was cat and mousing Google. So I was able to get those alternate websites I provisioned to like start generating revenue within a day or two, and they would not get banned for several days. So every time I launched one, like we'd get back up to making, let's say, like $4,000 a day, and then we get banned. And so I was like, what is going on? You know, I didn't connect in my head. And then I started hearing from other people online, like, oh yeah, there's this big search change and all these effects and stuff. So it took me a while to actually come to that understanding, but that was sort of how it worked out. Yeah. SEO stuff can be terrible though. Like it could be, game ending for a lot of companies and stuff. It's pretty crazy. Yeah. If you're in Virginia Beach and you want to share a story, by the way, feel free. If you just want to jump in, I think we can hear you on here too.
You want to share a story, Drew? You don't have a story? You're perfect.
Use key configuration data for environments as variables or inputs. If you don't, and people try to type Azure subscription ID, it tends to not work out.
It sounds like Drew's made a lot of security issues is what I'm hearing, or a lot of developer horror stories. He's laughing, it must be true.
That's the sound of me laughing to a bus pulling right over me.
I see. Well, thank you for coming, remote friends. I will kill the stream now, but thank you so much for coming. It's super cool to see all of you. And yeah, hopefully I'll see all of my San Francisco friends back in person in like a couple weeks, because our next meetup's in the Bay Area on the 27th. And when is your next one, Micah, in Virginia? Do you know? Oh, I'll stop that. Yeah, I got it. Cool. Well, it's great to see you all, and hopefully we'll see you in person next time.
Thank you. All right, great talk, man.
Oh, thank you. Bye. I'm going to end.